Hello, in this video let's learn to derive a transfer function from a set of state space equations. Equation 1 and equation 2 together are called state space equations. The transfer function is basically the ratio of output to input. Before proceeding further, let's take a quick look at the variables we have here. X of t is the states of the system. X dot is the derivative of states. P, Q, and N are number of inputs, outputs, and number of states respectively. A, B, C, and D are matrices, and these are the dimensions of these matrices. Okay, let's finally proceed to deriving the transfer function from equation 1 and equation 2. The main idea is to take the Laplace transform of these two equations. So let's start with the first one. We'll take the Laplace transform of the first equation. So refresh your memory, the Laplace transform of x dot of t is going to be s times x of s minus the initial condition is equal to a times x of s plus b times q of s. Okay, we'll collect all the x of s terms on one side. So s times x of s minus a times x of s is equal to b times u of s plus x of 0. That is si minus a times x of s is equal to b times u of s plus x of 0. And then x of s is basically si minus a inverse b times u of s plus si minus a inverse x of 0. Let's call this equation 3. And before I move on, let's make a comment here that this is the Laplace transform of equation 1. Okay, let's move on, and we'll take the Laplace transform of the second equation. Okay, the second equation was y of t is equal to c times x of t plus d times u of t. The Laplace transform of this equation is y of s is equal to c times x of s plus d times u of s. So what we'll do is we derive the x of s in the first equation. So we will plug in equation 3, which was x of s derived from equation 1, into this equation. So we have c times x of s. So let me just write here what we had. So equation 3 derived previously was basically x of s is equal to si minus a inverse b u of s plus si minus a inverse x of 0. Okay, we'll plug that in here. So si minus a inverse b u of s plus si minus a inverse x of 0 plus d times u of s. Okay, alright, so let's collect u of s terms. So c si minus a inverse b times u of s plus d times u of s plus si minus a inverse x of 0, which basically is csi minus a inverse b plus d u of s plus si minus a inverse x of 0. Remember, x of 0 is the initial condition. If the initial condition is 0, then all of this term reduces to 0, and all we have left is y of s is equal to this term C Si minus A inverse B plus D U of S. Now remember, the transfer function was basically the ratio of output to input. So that gives us Y of S divided by U of S is equal to C Si minus A inverse B plus D. And this is your transfer function, which we called as H of S. So the key is, anytime you're given a set of state space equations, we know the matrices A, B, C, and D. We can easily find the transfer function of a system from those equations. I hope this video helped. If there are any questions, please post below. Thank you.